is from UET Taxila, Arslan Suleman. He will be talking about experimental study of double bridge pier scouring after installation of broad crested trapezoidal weir at downstream. So I will request the presenter that he should limit within 10 minutes. When I say time is up, please then go to the conclusion. Go ahead, Arslan. Please start your presentation and make your presentation, shift your PowerPoint to the presentation mode.
Oh, okay, sir. I'm trying.
Your presentation is visible. Your voice is coming. Please go ahead.
Assalamu alaikum to everyone. I hope you are all fine. And first of all, I thanks to Center of Excellence and all the organizers who arranged this conference. Today's my research topic is experimental study of double bridge pier covering after installation of broad crested trapezoidal weir at downstream. My paper ID is 102. And here is the table of contents, introduction, literature review, problem statement, aims and objectives, methodology, results and discussions, conclusion and recommendations. Whenever we place a hydraulic structure in way of water, it creates a turbulence around the structure, and as a result, the scuppering occurred around the periphery of that structure. To be more concise, there are three types of scupper that made overall scupper. These three are general scupper, contraction scupper, local scupper. General scupper, in which the amount of sediments of a river is carried out by downstream by fluctuating in water velocity because of regions cover in the bed and banks of the river. And cover is a result of narrowing the flow section of the river. This type of cover mainly occurs in
Mr. Arslan, sorry for interruption. Please go to the slide share option. You can go to the slide share option by clicking F5 button.
Oh, okay, sorry. Sir, can you see my share screen of presentation?
No, your screen is not visible now.
Oh. So, can you see now?
No, I am not seeing. Now is it visible?
It is, Azaz, it is visible to me. Maybe you change your connection. Go ahead, Arslan. It is visible to me.
Sorry, it's visible.
Okay, sir. Thank you.
Go ahead.
And the last is the local cover occurs when any structure such as bridge pier may change the flow pattern and create a local cover turbulence flow, which includes a downflow and wake vortex. Downflow occurs in front of a cylindrical which carries sediments in node and around the bridge pier. Here's the problem statement. Scuppering effect is one of the main reasons in the bridge failures. It has been known from the previous research that scuppering has a considerable effect by the shape and geometry of the pier and the other countermeasures like submerged weirs, bed seals, sharp-crested rectangular submerged weirs. This research aims to experimental study of double bridge piers covering after installation of broad crested trapezoidal weir at downstream. Since there is no study conducted so far as on a trapezoidal weir of at downstream pier simultaneously. Here is the aim and objectives. The main objective of this research is to evaluate the locals covering around double bridge pier at different discharges. To investigate the locals covering around both bridge after installation of submerged broad crusted trapezoidal weir at downstream. To compare the local covering around double bridge pier with and without the presence of downstream submerged trapezoidal weir. Here is the methodology which I used to carry out all the experiments. First of all, I want to share the plan of the laboratory flow which I used for the experimentation. You can see here is the discharge control valve, and that from where the discharge and flow water enters in a well, and here are the strainer pipes from where the turbulence minimizes. And this section is for the experiment which I installed trapezoidal weirs and bridge pier model. You can see here the sediment bed which I use 15 centimeter thick sand, and here is the tailgate and weir installed at the end of the laboratory flow, and at last there is a sediment trap from where the water recycled from the storage tank and then recycle it from the main channel. These are the experimental pictures for circular shaped bridge and the length of the channel is 20 meter and 1 meter width and 0.7 meter in depth. Water is circulated through 9.4 HP centrifugal pump having changeable speed option controlled by valve. The pump was capable to deliver around 500 US GPM of discharge. At the entrance of flow, 75 straightener pipes were installed to reduce large-scale turbulence and circulation at the upstream. The experiment was carried out with 8-meter sediment bed having thickness of 15 centimeter, and the upstream pier was in the third of the zone to ensure the formation of fully developed velocity profile at the working section. The pier were installed at 0D, 2D, and 4D, and 6D. Basically, D is the distance equal to the diameter of the pier, which I adopt as 6 centimeter diameter of the pier, from where the weir installed in the test section. All the experiments were conducted at 5 different discharges, 20 liter per second, 25 liter per second, 30 liter per second, 35, and 40 liter per second. The flow discharge was determined with a trapezoidal weir at the end of the channel placed after the tailgate, which I show on the pictures. Here is the methodology which I adopt and the calculation of fraud number and the distance at which I place the weir at a distance of 0D, 2D, 4D, and 6D. These are 3 types of piers which I use: circular shaped bridge pier, hexagonal, and square shaped bridge. These are the contour maps which I plotted by using the surfer software. You can see here is the circular contours for circular bridge pier, and these are the bridge contour for hexagonal bridge pier, and finally the square bridge pier. From the experiment and by calculating the volume of cover, it is observed that the maximum cover occurs in square bridge pier, and then minimum in hexagonal pier, and the least in circular bridge pier. Here is the graph representing the distance of pier from weir and the dimensionless cover on the vertical axis. As you can see, as the distance increases from the pier from the weir, the covering increases. If you see at 0D, the covering is minimum. As we increase the distance from the pier, the covering increases. And same further goes for 4D and 6D. The maximum covering occurs at 6D. from the weir.
Last minute for you, please.
Okay, sir. I'm going to conclude my presentation. I just want to share my graphs. So here is the dimensions cover versus in flow intensity. This is for a circular shape bridge pier, and this is hexagonal shape bridge pier. And you can see the maximum covering occurs in case of square bridge shape when when the distance is 6d from the pier. Here is the longitudinal covering profile of the bridges. This is the upstream side. When the water strikes the pier, it creates turbulence, which create scuppering at the upstream and the deposition at the downstream of the pier. Here you can see there is maximum covering at the upstream and the deposition of the sediments at the downstream of the pier. And here is the conclusion. I want to conclude my research. This experiment study was conducted to assess the most efficient and an optimum pier shape in terms of reducing cover depth. It also presents the capability of various pier modification to minimize the erosive power of flow acting on the riverbed. The data reveals that the dimensionless maximum cover depth ds over dA is maximum for vertical square-shaped bridge, and it decreases when the distance decreases from the pier. The cover depth around a square-shaped bridge pier is greater than the cover depth around a circular and hexagonal models at all 5 flow conditions. The flow velocity exhibits a direct relation with cover depth around a pier. Similarly, an increase in flow velocity increases the cover depth because of its erosive action until it reaches the critical velocity, which tends to bring sediments to the cover hole from upstream, causing reduction in pier cover depth. The contour maps drawn under different conditions of flow, sediments, and pier geometry effectively reflect and exhibit the extent of covering process. That is also represents the degree of remedial measures. And that's all today. And that's the end of my presentation. Thank you, sir.
Thank you very much, Arslan, for your nice presentation.